Calculate your future, the value of a mathematics and statistics degree. The Department of Mathematical and Statistical Sciences at the U of A is one of the largest departments of its kind in Canada, with our math programs ranked as number 5 in the country. Statistics, economics, and finance are also ranked in the top 10, and all of our math-related programs are ranked as top 150 in the world. Our students have the opportunity to learn from professors who are recognized not only for their research, but for their dedication to teaching. This means that you gain the most up-to-date knowledge from individuals who are excited about their disciplines and are in the top of their field, whether it be through developing different streams of introductory calculus to help students better connect concepts to the real world, initiating community math programs for Indigenous youth, or starting an 8 a.m. math class by playing guitar and making up a song about derivatives and limits. Professors help to build your confidence and inspiration to learn. As a research-intensive university, we want you to get involved in research. Mathematical research can be difficult to explain if you haven't been exposed to higher-level concepts such as quantum curves, convex geometry, quotient rings, or orthogonal polynomials. But students will have the opportunity to conduct research alongside professors who are using math and statistics to investigate the next generation of wireless communications, model the movement of cancer cells in tissues, evaluate if artificial intelligence is performing responsibly, and tackle theoretical questions related to risk and the structure of financial markets. uab.ca/URI is a great resource for students to start getting involved in research, and there's even opportunities for high school student summer research. Stumped by a tricky homework question? We're here to help. The Decima Robinson Support Center offers comprehensive support for students taking introductory calculus, linear algebra, and statistics courses. The center is staffed by graduate students who are available for free drop-in support and exam study sessions. We also offer summer primer courses to help ease your transition from high school to university math, as well as a 6-week pre-calculus program. Fun fact, the Decima Robinson Support Center was named after the first Bachelor of Science graduate at the University of Alberta in 1911, Decima Robinson. She was also the very first mathematics major. Do you enjoy solving math problems for fun? Well, the Department of Mathematical and Statistical Sciences has a long history of participating in mathematical competitions and challenges, such as the Putnam and Prima Risk Management. These contests challenge teams of students to clarify, analyze, and propose solutions to open-ended or realistic business problems to win up to $10,000. Or you can get together with friends and create a mosaic with 400 Rubik's Cubes just for fun. Here's a Rubik's Cube portrait of Margaret Ann Armour, a chemist and inspiring supporter of women in STEM. Now let's talk about programs, which range from being broad and flexible to structured and specialized. A major degree is our most flexible degree program where approximately half of your courses are in one main subject area and the rest can be elective courses. Most students add a minor, which then allows you to design your degree around 2 areas of interest, plus still have lots of room to add elective courses from almost any subject. An honors degree is for students who are passionate about and fully committed to their area of study. Topics are studied in depth, and students reach the level of rigor used by practicing mathematicians and statisticians by the time they graduate. The biggest difference between major and honors is that there is an added senior research project in honors, which is taken during the final year. These students are expected to maintain higher grades than those in the major program. Both of these degree types are 4 years in length if taking a full course load, but can be taken part-time. We also offer a 5-year Bachelor of Science, Bachelor of Education combined program, allowing you to graduate with 2 degrees if you're interested in becoming a secondary school math teacher. Within the major and honors program, there are 29 different areas of study to choose from, but today we'll focus on the 6 math-related programs. So all you want to do is study mathematics? That's fine by us. Just like you do, we see the beauty in all mathematics and want to give you the opportunity to experience as much of it as possible. Many people refer to this program as pure mathematics. Pure mathematics often derives its inspiration from physical ideas with extraordinarily important applications in other areas of science and technology. It's primarily pursued by those who are fascinated by its wealth of wondrous ideas and its perfection of detail. Mathematics can be taken as a major or honors program or added as a minor to a program in a different subject area. A mathematics major is offered through either the Faculty of Science or Faculty of Arts. What's the difference between a science math and an arts math degree? Well, the courses are identical, except that science students must take 2 additional fourth-year classes, and art students must take 2 language classes in order to graduate. The only other difference is admission requirements, which I'll get to at the end of the presentation. The programs offer plenty of flexibility so you can steer your studies in the direction you are most passionate about, including analysis, coding theory, differential equations, functional analysis, geometry, or number theory. Most pure mathematicians are employed by universities, colleges, and research institutes, although an increasing number also branch out into the commercial sectors, especially financial, market analysis, and computing, where their ability to isolate, abstract, and formulate the essence of a problem is considered an invaluable skill. The division between pure and applied mathematics is not well defined, and many students choose to develop skills in both areas. Many of the most famous mathematicians were and are deeply committed to both aspects. Applied mathematics can be taken as a science major or honors program and will train you to apply mathematical ideas to solve practical problems in the physical, social, and life sciences, as well as in engineering and finance. With its combination of pure and applied courses, the program delivers the theory you need while putting the focus on more practical application. Course topics can include partial differential equations, numerical methods for solving nonlinear equations, introduction to computing programming, and students can also focus on modeling specific to life sciences such as epidemiology, ecology, population biology, physiology, and medicine. Students are encouraged to recognize and formulate problems in mathematical terms, solve the resulting problems, and interpret the solution in real-world terms. For example, a new 3D mathematical model developed by U of A scientists can describe the movement of a figure skater across the ice. This helps answer questions like, if I want to make this movement or this pattern, what do I need to do with my body? What is the optimal way to do it? Models like this could help skaters avoid common injuries or could potentially be applied to boot or blade design. We now offer an embedded certificate in applied data science that any student can add to their degree. It's only 6 courses that you can incorporate into your degree in any of the subjects listed and includes a final project. Courses can range from machine learning and visual recognition to weather forecasting or determining the physical properties of the Earth through ground-penetrating radar. The choice is yours. Mathematics and economics is offered as either a science major or honors program. These focused programs allow students to engage in coursework that applies mathematics in a business and economic context and choose from a wide variety of courses in mathematics, statistics, economics, and computing science, providing you with opportunities to tailor the program to your interests. Topics can include calculus and linear algebra, probability theory, econometrics, micro and macroeconomic theory. Economists rely heavily on mathematical and statistical methods when they study how a society produces, consumes, and distributes goods and services. You will not only learn the essentials of economics and related tools, but also better understand the mathematics and statistics behind these tools. These programs prepare students for employment in many sectors of the economy, including governmental organizations and large companies in finance, insurance, or real estate. You can graduate as an apprenticed economist, but the designation of professional economist usually requires a master's degree. Bachelor of Science in Mathematical Physics. In the history of science, there was very little distinction between mathematics and physics, and in the modern era, the two fields have evolved separately but continue to be very closely connected. On the one hand, mathematics is an essential tool for physics. It is the language that we use to formulate physical models. From calculus to algebra, geometry to group theory, mathematics is fundamental to theoretical and experimental physics. On the other hand, physics is a fantastic source of insight in mathematics. Not only are mathematical structures often developed for the needs of physics, but modern theoretical physics has also been the origin of profound new developments in pure mathematics itself. The synergy between the two fields is pretty remarkable. This program can be taken as either a major or an honors, and topics will cover how to describe and analyze physical systems mathematically, classical mechanics, quantum mechanics, thermodynamics, and relativity. The programs will introduce you to a wide variety of physical models and the beautiful mathematics underlying them. Graduates of the mathematical physics program are well suited to postgraduate studies in mathematics, applied mathematics, physics, and engineering. Many establish careers in research, taking up academic positions in universities, colleges, and research institutes. An increasing number of graduates branch out into the commercial sectors, working in areas such as computing, financial market analysis, medical physics and imaging, data analysis, and more. The ability to formulate and solve problems that is developed in the mathematical physics program is highly sought after in the private sector, so the possibilities are endless. Pictured here is a physics professor whose research focuses on the unusual geometry of hyperbolic crystal lattices that can be fabricated in the laboratory. His team is creating a framework to describe the motion of electrons through these lattices and how this can be used in real-world applications such as computer chip technology and quantum computing. A Bachelor of Science in Statistics can be taken as a major or honors program or added as a minor to a program in a different subject area. Statistics programs will train you in the rich discipline of collecting, analyzing, and interpreting data. And you can choose from an extensive selection of courses on subjects ranging from the experimental, such as sampling techniques and statistical inference, to the theoretical, such as probability theory and stochastic processes. For instance, biomedical researchers use clinical trials to investigate the effectiveness of new treatments. Agricultural scientists use field experiments to evaluate irrigation methods. Or ecologists gather water samples to measure the quality of water, which is what one mathematics student did for an internship placement with the Government of Canada. Statistics is an area that calls for strong mathematical skills and an interest in problem solving. Our programs therefore include a strong foundation in mathematics. Graduates from programs in statistics are highly sought in a wide variety of fields. For examples, many become researchers in government agencies such as Alberta Environment, biostatisticians in hospitals and medical research facilities, actuaries and financial analysts with insurance firms, pension administrators, or even survey methodologists with Statistics Canada. Graduates from our Honor Statistics program are well positioned to become accredited as an associate statistician or as a professional actuary. Are you fascinated by the seemingly random movement of stock prices? Or have you ever wondered if such movements could be modeled and simulated? Maybe our program in mathematics and finance is the right choice for you. Since this is an interdisciplinary area whose understanding requires a broad education, the programs also include courses from statistics, economics, accounting, and operations management. Mathematics and finance degrees are jointly offered with the Faculty of Business and are non-direct entry, meaning that students wishing to pursue this program must complete specific courses in their first year in order to transfer. These are quota programs, meaning that only a limited number of students can be registered in these programs, and therefore admission is competitive. A degree in mathematics and finance provides a solid foundation for careers in the financial industry and graduate studies in financial engineering and mathematical finance. Graduates of our program can apply mathematical and statistical techniques to analyze financial products and manage financial risk. They find employment in all areas where quantitative skills combined with financial understanding are required. For example, at banks and investment firms in areas such as development of trading strategies, portfolio analysis, and risk management. Honors Statistics and Honors Mathematics and Finance students are well positioned to complete requirements for certain professional designations after graduation, such as Associate Statistician, Professional Actuary, Chartered Financial Analyst, Energy Risk Professional, financial risk manager, or professional risk manager. Students can take courses in their degree that are pre-approved to help meet these designation requirements or that are useful for certification exams after graduation. Our last degree type is the Bachelor of Science, Bachelor of Education combined degree for those of you who are thinking of becoming math teachers. This is a 5-year program and you graduate with 2 degrees. Students follow a structured full-time course curriculum and choose from a combination of majors and minors in biological sciences, mathematical sciences, or physical sciences. Graduates of this combined degree will be certified to teach all subjects in grades K to 12 within Alberta curriculum schools. However, the program is specialized for teaching science to grades 7 to 12. Internships integrate university studies with relevant paid work experience. Minimum placements can be between 4 to 18 months, depending on whether you're in a science or arts program. We host resume and cover letter workshops to help assist in connecting students with companies for work term periods. Placements can be local, provincial, national, or international. And students are actually more motivated and focused to complete their remaining courses after gaining insights into the professional world. An internship can add time to your degree, but there are major benefits, and it's an ideal way to start building a professional network and figure out what you want to do with your degree while still in school. A recent mathematics student did their internship with CIBC Bank as a cash management analyst. What can I do with my degree? Well, studying mathematics develops your problem-solving skills, trains you to think logically, and helps your decision-making abilities, all of which are valued by employers in many, many industries. Employers are interested in graduates of all of our programs because of the skills they acquire. Not only do we train our students to think with precision, but we also nurture their creativity and ability to solve problems. You can visit uab.ca/science careers to see some companies that our students have worked with during internship placements. To summarize, there are a lot of different ways to study math within the Faculty of Science and a few within the Faculty of Arts. Here's a nice summary table of these subjects and whether they're offered as a major, minor, or honors degree. So let's talk about admissions. Admission to the Faculty of Science mathematics-related programs is assessed on your marks from 5 core high school subjects. A competitive admission average will be in the low to mid 80% range, but could be higher depending on the applicant pool. All science programs require English 30-1, Math 30-1, 2 grade 12 science courses, plus 1 other course. I've underlined Math 31 Calculus as it will be a prerequisite for some of the courses that you'll be taking within a math-related program, so it's a good idea to take it in high school. Physics 30 will be a prerequisite if you're considering the mathematical physics program. You can visit uab.ca/programs for a list of specific courses that fall under that final 5th course category of fine arts, humanities, and languages other than English. And as mentioned, the mathematics and finance programs are non-direct entry from high school and require a year of specific courses in the regular math program before you can apply to transfer. Admission to the Faculty of Arts Mathematics degree is different than the Faculty of Science and is very flexible in that the only specific course required is English 30-1. The other 4 courses can be from a variety of subjects. Technically, you can be admitted to the Arts Math program with Math 30-2. However, to be successful and register in your first-year math classes, you will need to have Math 30-1. Admission averages through the Faculty of Arts is typically in the low 70% range. And again, visit uab.ca/programs for more details on specific coursework. And if you have any questions about our Faculty of Science programs, please feel free to contact our student recruitment team at science.recruiting@ualberta.ca. We look forward to seeing you at the University of Alberta.